Hello dear students, I am your educator Burhanuddin and it's time to cram. So this is the sixth video lecture of chapter 12 class 10 electricity, and in today's video lecture we are going to learn Ohm's law and we will see that what is resistance. We start with the very first question, that is there is a relationship between potential difference across the conductor and the current through it. So is there is a difference between potential difference and current means V and I. Now you know what is V and what is I. V is our potential difference and I is our current. So let us explore with 10 activity. So materials required for the activities are a dry cell, a conducting wire, a ammeter, voltmeter, thin iron rod, or you can also take nichrome wire, LED and key. So in my previous videos I had already talked about what is ammeter and what is the use of ammeter, and what is voltmeter and what is the use of voltmeter. If you want to watch that videos, then click the I button. Now connect all these components. First take a battery, then connect one terminal of battery with ammeter in series and another terminal of ammeter with switch. Now connect another terminal of switch with iron rod and other terminal of and positive terminal of battery with another end of the iron rod, and connect voltmeter in parallel connection with iron rod. So I already told that we have to connect ammeter in series and voltmeter in parallel connection. So after completing this connection, switch on the key and note the reading from the ammeter. So here we can see some reading showing ammeter and voltmeter. We have to note down this reading. So note down this value in the table given in your textbook. So here how many cell we had used? So one cell, and the potential difference which is shown by voltmeter is 1 and the current which is shown by ammeter is 0.5, and the resistance of iron rod is 2 ohms. We will take it as constant. Now second time replace one battery by two batteries and again switch on the circuit and note the reading of voltmeter and ammeter. Here the number of cells used in a circuit are 2. The potential difference shown is 2. The current shown by ammeter is 1 and the resistance by iron rod is 2 ohms, which is constant. Now repeat the same activity by adding one cell after each observation. So for 3 cells the potential difference which is shown by voltmeter will be 3 and current will be 1.5. If we use 4 cells, then potential difference which voltmeter will show is 4 and the current shown by ammeter is 2 ampere. And if we replace these batteries, if we use 5 batteries or cells, and if we use 5 cells, the potential difference shown by voltmeter is 5 volt and current shown by ammeter is 2.5 ampere. So here what did you notice from the table? You can notice here that first time voltage shown was 1, another time 2, another time 3. So it is gradually increasing by 1 volt. Same here you can notice that the current which is shown was 0.5 ampere and another time it was 1 ampere. The next time it was 1.5 ampere. So what is the difference here? The difference is 0.5 ampere. So here we can say that the current is gradually increasing by 0.5 ampere, which is constant for all reading, and here the voltage is gradually increasing by 1 volt, which is constant for all reading. After plotting graph from the point obtained from the activities, we can find a straight line from origin. So in this activity you will find that approximately the same value of V versus I is obtained in each case. Thus V versus I graph is a straight line that passes through the origin of the graph as shown in the figure. It means that for first case the voltage obtained was 1 and the current obtained was 0.5 is equal to 2. Another time the voltage obtained was 2 and the current obtained was 1. So the ratio will be equal to 2. In next reading, the voltage obtained was 3 volt and the current obtained was 1.5 ampere. After taking this ratio, we will get answer 2, which represent that V versus I is a constant ratio. So in 1827, a German physicist Georg Simon Ohms found out the relationship between the current I flowing through a metallic wire and the potential difference across its terminal. He stated that the electric current flowing through the metallic wire is directly proportional to the potential difference V across its end, provided its temperature remains constant. So he stated that potential difference through a conductor and the current through a conductor are in proportionality relationship. He observed this after doing the activity with the condition that temperature must remain same, and this is known as Ohm's law because it was stated by Simon Ohms. In other words, we can say that V is directly proportional to I, and so in any mathematical equation, if we have to replace this proportionality symbol with any constant. So we can write this equation like this, that V is equal to constant into I. Now if we take I from left hand side to right hand side, we will get this equation, and here the constant which we have taken is R, and if we take I from left hand side to right hand side, we will get V is equal to IR, which is Ohm's law. We can either represent Ohm's law using this equation or using this statement. In V is equal to IR, the R is a constant for a given metallic wire at a given temperature is called resistance. So yes, this R is called resistance, and it is the property of a conductor to resist the flow of charge through it. Here from the word resistance, you can state its property, that its property is to resist the flow of charge through it, and its SI unit is ohms as it was given by Ohms. So the law is known as Ohm's law, and for his constant R is ohms, represented by a Greek letter omega. This is the symbol of omega, or we can also tell it as ohms. We have to make this symbol like this. And according to Ohm's law, V is equal to IR. If we make R as a subject, so we can write it as like this also, that R is equal to V by I. So resistance is ratio of voltage across the end of the metallic wire by current passing through it. If the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R of a conductor is 1 ohm. So your examiner can ask a question that define 1 ohms. So you have to define it that the potential difference across the conductor is 1 volt and the current through is 1 ampere, then the resistance R across the conductor will be 1 omega. So from Ohm's law, V is equal to IR. If we make R here subject, so we can write R is equal to V by I, and here V is 1 volt and current is 1 ampere. So answer which is obtained is 1 ohms. Also from this V is equal to IR equation, we can write I is equal to V by R. Also from equation, we can write I is equal to V by R. So it is obvious from the equation that current through a resistor is inversely proportional to its resistance. As we had seen here that V is equal to IR, I is equal to V by R. So here current is inversely proportional to resistance. If the resistance is double, the current is half. So if we make this resistance 2 times, then the current will be 1 time. In many practical cases, it is necessary to increase or decrease the current in an electric circuit. a component used to regulate the current without changing the voltage source is known as variable resistance, and we called that variable resistance as rheostat, as I already told you in my previous class. The topic which will be covered in next video lecture is activity 12.2. In this activity we will learn that how current is different for different components. So stay tuned for it. Notes are uploaded on the bloggers page of Time to Cram. So visit the bloggers page to download the notes, and the link of the bloggers is given in the description box. So check the description box, get the link and download the notes. And if you find this video helpful and informative, then like it and do share it with your friends and classmates. And yet you had not subscribed to our channel Time to Cram, then subscribe it. And don't forget to hit the bell icon so that you will get latest notification and update when new video is uploaded. That's all for today's video lecture. Thank you.